previous videos, we have been learning how regression problems are approached through a neural networks framework. What were the other two AI sisters that you talked about, Dr. Murthy? How do we deal with those through a neural networks framework?
Okay, but let's look at the second sister, which is classification. Now, the problem with the classification is that um, the problem with the classification here is in a regression, when I gave x1, x2, x3, I have to get a value y, and I can learn w1, w2, w3. That can give me the y. Fairly simple. But in the classification, my y is a behavior. You see, will the customer churn or not? Is it a COVID or is this patient having COVID or flu, or is he healthy? So my target, the y that I have to predict, it's called target, is a categorical attribute in a classification. It can only take a few values. So if it's binary classification, I can code such that my target can take 0 or 1 or -1 and 1. Either of them. I can code it anyway. Convenient is to code it as 0, 1 or -1 and 1. I can code it as 100 and 284. It doesn't matter. All I'm saying is one class is 0, the other class is 1. One class is -1, the other class is 1. Similarly, if I have multiple classes, I can again code it as 1, 2, 3, 4. But normally what people do is code it as a dumb one hot vector. What is a one hot vector? Let's say I have to code it between COVID, seasonal flu, and healthy. For COVID, I code it as 100. For seasonal flu, I code it as 010. For healthy, I code it as 001. Again, I can code it whichever way. As long as I'm consistent, it's fine. But this simple construction doesn't give me a 0 or 1 value or -1 or 1 value. It can give me any value from -infinity to infinity, depending on x1, depending on w1 values. It can give me anything. So I need to do some more work to get the y back to that 0 or 1 or -1 or 1, something that I can map to my coding. Now, one way of doing is called apply a threshold function to y. So what do I mean by that? Hey, if y is less than 0, make y equal to 0. And if y is greater than 0, make y equal to 1. This is a definition that I will set. So whenever I get a negative value here, less than or equal to, let's say, negative or 0 value, I will make it 0. The output is 0. So I have one more function, f of y, where if y value is less than or equal to 0, the output will be 0. If the y value is greater than 0, the output will be 1. So this step of changing the y through another function is called activation of y. And the function, in this case, function is if it's less than or equal to, this is a very simple function. It can be more complicated functions. So f of y is called activation function. So one way to use the same setup to solve a classification problem is add an activation after I do this summation. So this you can think of it as a summation or a matrix multiplication actually. So w1x1 plus w2x2 plus w3x3 plus b. I got the y. Now I put that y in this function, and if y is less than or equal to 0, my output is 0. Y is greater than or equal to 0, my output is 1. So I have two steps. Normally what people do is they think of even regression as a two-step thing just to be consistent. But the activation in regression is unity. So activation in regression is a unity function. What does that mean? Hey, F is y is equal to y. F of y is equal to y, right? That's all it is saying. So in regression, also I can consider that I'm using activation, but hey, that is a unity function. But classification, you need a more interesting activation function.
I love the activation function. It solves classification problems so adeptly. Thank you for teaching us about that, Dr. Murthy.